combine all the stuff we've been learning in the other videos, and we're going to use that to solve these problems. So for number 18, we have the patient's unaided acuity is 20/70, and their keratometry findings are 44.12 at axis 22 and 46.12 at axis 112. So we just have to take this step by step. So we know the patient's acuity is 20/70. On Egger's table, we know that that's minus 1.50 as their spherical equivalent. Not their sphere, their spherical equivalent. So now we have to figure out the keratometry stuff. So the axis we're going to use is 22 because it applies to the smaller number, which is 44.12. So our axis is 22. Our sill, our corneal sill, is these two numbers subtracted from each other, which in this case is minus 2. And now we go from corneal sill to spectacle sill. She doesn't specify Javals versus modified Javals, so we'll just do modified Javals. This is with the rule because 22 is within 30 of 180 and or 0. And so since it's with the rule, I know that the power is going to go, like the sill value is going to go down by 50. So our final corneal sill is going to be minus 150, axis 22. And so this is our final sill for our answer. So the question is asking for our spherical cylindrical Rx. We already have most of it. So our is going to be sphere sill axis. We know our sill is minus 150. We know our axis is 22. We just need to figure out the sphere. And to do that, we do a formula, which is spherical equivalent equals sphere plus half of the sill. So in this case, we know our spherical equivalent is minus 150. Our sphere is, we don't know, it's a variable. I'm going to use x instead of s, plus half of the sill, which is minus 1.50. Be careful with your signs here. So minus 150 equals x plus minus 150, I'm sorry, minus 75, which is the same thing as saying x minus 75. So then we just add it to both sides. So add minus 0.75. And so then our final answer is minus 150 plus 75 is minus 0.75 equals our sphere. So this is our final answer, minus 0.75, minus 150, axis 22. Okay, and then let's do number 19. Your patient sees the 0.4 M line clearly at 25 centimeters, and that's their keratometry readings. So 41.25, 41.50 at 100. Okay, this question is really tricky, so pay attention. This is the kind of thing you'll see on the exam. So your patient sees the 0.4 M line at 25 centimeters. So this means 25 centimeters is our punctum remotum. So if we do 100 divided by 25 centimeters, we get minus 4 as our spherical equivalent. So this is the part you need to pay attention to. So this says at 100, not axis meridian 100. So this 100 axis applies to this number, which means it's not the axis we're using for our answer because this number is the lower number. So to find the axis of this number, we just do 100 plus or minus 90. In this case, since it's over 90, I'll subtract 90 and I get axis 10. So our answer is axis is 10. And then the corneal sill is, if you subtract these, it's minus a quarter. So is this against the rule, with the rule, oblique? This is with the rule. And so this part, pay attention as much as you can. When we have a with the rule, we're going to decrease the sill by 50, which is the same thing as minus 0.25, subtracting minus 50. So minus 0.50, which is the same thing as minus 0.25 plus 0.50. So if we do all of that, our math leads us to an answer of plus 0.25, axis 10. The problem with this is we don't keep our cells in plus. We always use minus. So to go from a plus cell to a minus cell, what you do is you take the symbol, so plus, we flip it to minus. We keep the same cell number, and we just flip the axis by 90 degrees. And so if we add or subtract 90 from 10, we get axis 100. Okay, so we have our final cyl. So we're still trying to find our Sphero Cylindrical Rx. So we have sphere, cyl, axis. Our cyl is minus a quarter. Our axis is 100. And now we have to solve for the spherical, the sphere portion. So our spherical equivalent, we do spherical equivalent equals sphere plus half the cyl. So our spherical equivalent is minus 4, equals sphere, which is, we'll use x, plus half of minus 0.25. And so we get minus 4 equals x, plus minus 0.12, which is the same thing as just doing x minus 0.12. We add 0.12 to both sides, plus 0.12, and then we get x equals 3.88, 3.87, somewhere around there. Okay, this is the part you really need to pay attention to. Remember, this is a minus number. So when we're rounding for sphere or spherical equivalent, either on one of those, we round in the more minus direction. Okay, so minus 3.87, we're going to round to the more minus number. So right now we're between minus 4 and minus 3.75. I'm going to pick minus 4 because it's the more minus number. So our final answer is going to be minus 4 minus a quarter, axis 100. Now, I just want to show you something. So ignoring all the math that we did here, hypothetically, if we solved for our spherical equivalent and we ended up with something like plus 3.87, again, we're between plus 4 and plus 3.75. But in this case, I would pick the plus 3.75 because that's the more minus number. So you have to differentiate between rounding up and rounding down. We're rounding in the more minus direction, whichever direction that may be. And so I'm just going to reiterate it one more time. For sphere and spherical equivalent, we round in the more minus direction. For cyl, we round in the more positive direction. Okay, let me erase this. Okay, and then we'll do number 20. Your patient's acuity is 2015. With the plus 250 glasses, they read 2050. So we know 2050 on Egger's table is minus 1, but they're wearing the plus 250 glasses, so we combine them, and our spherical equivalent is plus 150. The keratometry readings are 47.62 at 37 and 48.12 at 127. Our axis is going to be 37 because 47.62 is a lower number. And the difference between these two numbers is minus 50. So this is our corneal cyl. And now we want to do modified Javals to go to spectacle cyl. But the thing is, 37 is, it's oblique. So that means the corneal cyl and spectacle cyl are the same. So we're just going to keep the spectacle cyl as minus 50, axis 37. And then we have our sphere cyl axis, so minus 50, x 37, and we have to solve for the sphere. So the spherical equivalent is plus 150 equals our sphere plus half of minus 50. So plus 150 equals x minus 0.25. And we add 0.25 to both sides, plus 0.25. And we end up with plus 1.75 equals x. And so that's our sphere. And so we have for this problem, number 21, it says after refraction, you determine your patient's Rx to be plus 1 minus 5 axis 10, they can't tolerate that amount of SIL. So what would you prescribe if you prescribed half the SIL? What would you prescribe if you prescribed 1 diopter of SIL? So the lesson that Dr. Nyman is trying to give us with this problem is that different prescriptions can have the same spherical equivalent. So our goal with this is to find the original spherical equivalent and then find new prescriptions that satisfy that spherical equivalent. So the original spherical equivalent is +1 -5 axis 10. And for the spherical equivalent, we do SE equals sphere, which is +1, plus half of -5. And so that's +1 minus 2.5 equals minus 1.5. Okay, so that's the spherical equivalent of our original prescription. So SE equals minus 1.5. So when we find the rest of the prescriptions, they should all have the same spherical equivalent of minus 150. So now we're saying we want to prescribe half the SIL. So we know the SIL is going to be minus 250. Axis is going to stay the same, 10. And now we just have to find the sphere. So we can do our formula, which is spherical equivalent, in this case minus 150, equals sphere plus half of minus 250. If we do that, we get minus 150 equals x minus 1.25. We add 1.25 to both sides, and we get x equals minus 0.25. Okay, and so whenever I do these problems, after I'm done, I just look at my final answer and I decide whether or not it makes sense. So if I took half of this, it'd be minus 1.25 minus a quarter plus minus 1.25 equals minus 150. So the answer makes sense. Okay, and then the final situation is we know the SIL we want to give is minus 1, same axis, and we still need to find the sphere. And so we do spherical equivalent, which is minus 1.5 equals sphere plus half of the SIL, which is minus 1, and we get minus 150 equals x minus 0.50. So x equals, if we add 50 to each side, x equals minus 1. So our final answer is minus 1, axis 10. And then I'm just going to look at my answer to make sure it makes sense, which we have minus 1, so half of that is minus 50. And so if we add minus 1 to minus 50, we get minus 150, and that makes sense.